Okay, Math 7, we are moving on to section 2.6. This is called prime factorization. So our objective today is to be able to find the prime factorizations of composite numbers. Okay, so the first thing is what is the difference between a prime number and a composite number? So a prime number can only be divided by 1 and itself. And a composite number has more factors. Okay, so for example, the first one is 19. Can you think of any numbers that go into 19? Nope, just 1 and 19 are the factors, so that means that it's prime. What about 20? Well, I can think of lots of numbers that can go into 20. 1 can go into 20, 2 can go into 20, 4 can go into 20, 5 can go into 20, 10 can go into 20. So because it has all those factors, that means it's composite. What about 11? I can't think of anything besides 1 and 11 that go into 11, so that means that it's prime. But number 16, I can think of all sorts of numbers. 1, 2, 4, 8, 16. So that means that it's a composite. So you just had to be able to identify one or the other. Now I'm going to show you how to find the prime factorization of each of these numbers. And there are two main ways to do this. The first way is with a factor tree. Okay, and the cool thing about this is that you can take your number and you can break it into any two factors. So what two numbers multiply to 36? And the way that I do my tree might be different than the way that you do your tree. It doesn't matter as long as you do all your factoring correctly. So for example, maybe I would think of doing this as 3 and 12. 3 times 12 gives me 36. Okay, so 3 cannot be factored anymore, but 12 can. 12 can go to 3 and a 4, and then 4 can go to a 2 and a 2. So your factors are any of the numbers at the end of the branches. So for example, 3, 3, 2, and 2. So the prime factorization of this is 2 times 2 times 3 times 3, and you should write this with exponents. So 2 to the second times 3 to the second. Okay. So sometimes on our numbers, they're large numbers. I always try to pick something that's a little bit easier to divide by. So for example, if it ends in a 0, I would almost always pick a 10. 28 times 10. Okay, so what are my factors of 28? Well, I think of 4 and 7. 2 and 2. And then let's factor 10. 2 and 5. So once you've reached the end, you can circle all of your factors. It has to be at the end of the tree, though. And then you write them all out in order. So there are 1, 2, 3 2s, a 5, and a 7. So this is 2 to the third times 5 times 7. And that's your answer. Okay. So 24. Maybe I'll do this one 2 different ways, just to show you how factoring can look different depending on who does it. So maybe the first time I'll factor at 2 and 12. 2 and 6, 2 and 3. So 2, 2, 2, 3. So 2 to the third times 3. But let's pretend someone else did the problem. And they're going to factor it a little differently. So why don't you guys try to think of what are some other factors? What if we did 4 and 6? That works, right? Well, 4 is going to factor to a 2 and a 2. 6 is going to factor to a 2 and a 3. Well, look at this. 1, 2, 3 2s, and 1 3. So you still get the same answer. Okay, so 150. Again, make it easy on yourself. Take it right away to numbers that are smaller. 10 and 15. 15 would be 3 and 5, and 10 would be 2 and 5. So if we write these in order, 2, 3, 5, 5. 2, 3, 5, 5, which equals 2 times 3 times 5 squared. Okay, the other way to do prime factorization is with a step diagram. Okay, now there are a couple important things, and you always have to divide by a prime factor. So for example, a prime factor would be like 2, 3, 5, so it has to be a prime number. So that is one rule. It has to be divided by that. So you make a little step like this. So our first number that would go in there, usually you start with a 2. Okay, so 2 goes into 242 how many times? Well, it's basically like dividing by 2. So I get 126. And then you're going to make a step and you're going to keep going. So can you divide 126 by 2 again? Yep. So 2 goes into 126 63 times. Well, what can 63 be divided by? It can't be divided by a 2, but it can be divided by a 3. 3 goes into 6 twice and goes into 3, so it's 21 times. Now, if you can divide by 3 again, you want to keep going. So I'm going to divide by 3. 3 goes into 21 7 times. Now, 7 cannot be divided by anything but 7. So that's the other thing, you kind of have to remember to do this too. 7 goes into 7 one time. Okay, so our prime factorization of this number, you always need to end with a 1. So our prime factorization of this number are all these ones on the outside. So 2 times 2 times 3 times 3 times 7, which is 2 squared times 3 squared times 7. And the last thing is you should be able to check any of these. So if you went 2 times 2 times 3 times 3 times 7, you should get back at your original number. Okay, so let's do our next one, 494. So let's divide it by, no, I'm going to divide this off to the side. 495. I know it can be divided by 2, but let's try 3. 3 goes into 4 one time. 3 goes into 19 6 times. And 3 goes into 15 5 times. So when I divide this by a 3, I get 165. Okay, let's take 165 and divide it by 3. 165 divided by 3 goes into 16 5 times. So it's 55. So I can divide it by 3 again, and you get 55. Now, I can't divide by 3, but I can divide by a 5. So how many times does 5 go into 55? 11. On your last little step is 11. That's divided by 11 one time. So I ended with that 1 again. So I get 3 times 3 times 5 times 11. 3 times 3 times 5 times 11. 3 squared times 5 times 11. And that's your final answer.